Alrighty, here is problem, well, really problems 3.1a, and then 3.2, I'm not sure exactly how we designate it, but A, and B, A, maybe? I don't know. But in A, so we're told that we have f of x equal 0 if x is strictly less than 5, and it's equal to a constant if x is greater than or equal to 5. So this is a CDF, cumulative distribution function, and it's continuous. And we're supposed to first find A so that this thing is a CDF. Actually, let's see. So for each of the functions given below, determine a constant A so that it possesses all the properties of a probability distribution function. That's a big PDF, uppercase. Determine in each case its associated probability density function, PDF, or probability mass function if it exists, and sketch all functions. Yeah. So I'm looking at this, and we have to do this. This first one's actually a bit more complicated, I guess. And this will go to number 2 or part B as well. They're messed up here. Now the reason they're messed up is, okay, we want x to be greater than or equal to 5. Oh no, they're not messed up. And I guess now that I look at it, I don't think this is continuous. Okay, so scratch that. So you see, I just started looking at the problem, and because I saw the x greater than or equal to 5, I thought, oh, it's continuous. But no, here's the thing is, I'm going to need a to equal 1. Okay, because this is a cumulative distribution function, and it has to be between 0 and 1, and always increasing. Well, but it's a constant once we hit x greater than or equal to 5, so it can't increase, and so it has to be 1. And so we have a equals 1, in which case we do have that 0 is less than or equal to f of x, which is less than or equal to 1. It's increasing, or non-decreasing is really the better term, but it's increasing. And so there we go. And so in this case, it's not continuous. It would need to be discrete because it has a jump discontinuity. So, right, if I draw this and I get to 5 here, it's been 0 all the way to here, and then all of a sudden it's 1. And so with a jump discontinuity there, we need to talk about a PMF, probability mass function. And so what we see is it all happens at 5. And so our PMF, little f of x, or p of x if you wish, is equal to, well, it's equal to 1 if x equals 5 and 0 otherwise. Okay, so it's a discrete probability distribution, and we just have that. F of x equals 1 when x equals 5. Now, if we go to 3-2a, just then wanted what's the probability that x is less than 6, less than or equal to 6, and well, that's f of 6, and so that's equal to 1. And in part B, they wanted what's the probability that 1/2 is less than x is less than or equal to 7. And so that's f of 7 minus f at 1/2. And so that's 1 minus 0. And it's 1. Okay, and so that's 3.1 and 3.2. And part A anyway for 3.1, and then what we do with that in 3.2. So there we go, 3.1.